Hello, I am Hema. Today I am going to discuss about linear equations in linear algebra, system of linear equations. What is a linear equation? It is an equation in the variables x1, x2, xn, and it can be written in the form a1x1 plus a2x2 plus an(xn) equals to b, where b is the coefficients and a1, a2, an are real or complex numbers, and they are usually known in the advance. A system of equations or a linear system is a collection of one or more linear equations involving the same variables, say x1, x2, xn. The solution of a system, it is again a list of s1, s2, sn of the numbers that make each equations satisfied. True statement when the values are substituted for x1, x2, xn respectively. The set of all possible solutions is called the solution set of the linear equations. Two linear systems are called equivalent if they have the same solution set. Now, which are the possible system of solutions? So, a system of linear equation has three types of solution, mainly. First one, the number solution, no solution. Second one, exactly one solution. And third one is infinitely many solutions. A system of a linear equation is said to be consistent if it has either one solution or infinitely many solutions. A system of linear equation is said to be inconsistent if it has no solution. A linear equation in variables x1, x2, xn can be written in the form a1x1, a2x2, an(xn) equal to 0 is called homogeneous system of linear equations. Such a system has two types of solutions. Unique solution, that is a trivial solution, that means all xi's are 0, and an infinitely many solutions along with a trivial solution. Now we will define what is the rank of a matrix. Rank of a matrix is mathematically we can find out the number of pivots obtained while reducing a matrix to a reduced row echelon form. So here, if a rank of a coefficient matrix A and a rank of an augmented matrix AB are same and equal to the number of columns, then the system will have unique solution. If a rank of a coefficient matrix A and the rank of an augmented matrix are not same, then the system has no solution. And if a rank of a coefficient matrix A and the rank of an augmented matrix are same but not equal to the number of columns, then the system has infinitely many solutions. The essential information of a linear system can be recorded compactly in a rectangular array called a matrix. For the following system of equations, here the matrix 1, minus 2, 1. Here the matrix 1, minus 2, 1, 0, 2, minus 8, minus 4, 5, 9 is called the coefficient matrix of the system, which is obtained from the coefficients of these variables. The augmented matrix is a system consists of coefficient matrix with an added column containing the constants from the right side of the equation. So this type of matrix is now called a coefficient matrix. The size of a matrix tells how many rows and columns it has. If m and n are positive numbers and Mn matrix is a rectangular array of numbers with m rows and n columns, then the number of rows always comes first. Here whenever we want to define, we always define a matrix with the number of rows first and columns afterwards. The basic strategy, consider the equation x1, x2, solving this system of equations, x1 minus 2x2 plus x3 equals to 0, 2x2 minus 8x3 equals to 8, and minus 4x1 plus 5x2 plus 9x3 minus 9 equal to 0. Here I want to pause for a minute and I am asking you a question. Think, if such equations, such systems are given, then which method we were using up till now? So everybody knows that we were eliminating one of the variable one by one, and then we were finding out the solutions of these unknowns. So it takes a long time and it is a long work. But if we use concept of linear algebra, then we will get the solution in a simple way. So the elimination procedure is shown here. Here we will construct first an augmented matrix. The first three columns are the matrix of a coefficient matrix, and last column is added, that is the column matrix B. And now we have to reduce this in a row echelon form. That means we have to use a row transformations to get a lower triangular in this matrix. So by performing that operation, we can have the following row echelon and reduced row echelon form. This is a row echelon form. Here only we are getting this triangular form, whereas in new reduced row echelon form, we must have zeros on on all the sides, on each and every element of a column containing the pivots. So you can see here, now if I want to find out the solution, then again I will have to put back substitution. So in this equation, if I go to the back substitution, then my first equation will be x1 minus 2x2 plus x3 is equal to 0. Second equation is x1 minus x2 minus 4x3 is equal to 4. And third equation will be x3 is equal to 3. So here we got the value of x3 directly. If I put the same value in the above equation, we can find out x2 and then x1. Whereas when we reduce it to a reduced row echelon form, then we can directly find out the solution, that x1 is equal to 29, x2 is 16 and x3 is 3. So these are the two systems we get after back substitution, and the only solution of the original system is 29, 16 and 3. Elementary row operations include the following steps: the replacement one row by the sum of itself and multiple of another row, interchange of any two rows, scaling multiply or entries in a row by a non-zero constant. The two matrices are called row equivalent if there is a sequence of elementary row operations that transforms one matrix into the another. It is important to know that row operations are reversible. If the augmented matrix of the two linear systems are row equivalent, then the two systems have the same solution set. Two fundamental questions about the linear system that I would like to ask you. First thing, is the system consistent? That is, does at least one solution exist every time? Second question, if a solution exists, is it the only one, that is the solution unique? So these are the two important things to be carried out. You think about this. Okay, thank you.